we're asked to find the angle theta over the closed interval from 0 to 180 degrees between the following vectors, where vector u is equal to -5 times unit vector I, and vector v is equal to 8 times the unit vector I minus 9 times the unit vector j, which means vector u in component form has an x component of -5 and a y component of 0, which is sketched here in blue, and vector v has an x component of 8 and a y component of -9, which is sketched here in red. Which means we're looking for this angle here, the angle between the two vectors in the closed interval from 0 to 180 degrees. Notice how there is a larger angle here on the other side. We'll be finding this angle here using the formula cosine theta is equal to vector u dotted with vector v divided by the product of their magnitudes. And we can solve this equation for angle theta by taking the inverse cosine or arc cosine of both sides of the equation, which gives us this equation here. And we know the output of inverse cosine is over the closed interval from 0 to 180 degrees, or from 0 to pi radians, which is why we'll be finding this smaller angle here between the two vectors. So let's begin by finding the dot product as well as the magnitude of the two vectors. So let's first find vector u dot vector v, which is equal to -5 times 8 plus 0 times -9, which is equal to -40. And now let's find the magnitudes of the two vectors. The magnitude of vector u is equal to the square root of the square of -5 plus the square of 0, which is equal to the square root of 25, which is equal to 5. And now let's find the magnitude of vector v, which is equal to the square root of the quantity 8 squared plus the square of -9, which is equal to the square root of 64 plus 81, which is equal to the square root of 145. So now we know that cosine theta is equal to the dot product, which is -40, divided by the product of the magnitudes, which is 5 times the square root of 145. And now solving this equation for theta, we take the inverse cosine or arc cosine of both sides of the equation, which gives us theta is equal to inverse cosine of -40 divided by 5 square root 145. And now we'll go to the calculator and find the angle theta in degrees as well as radians. And we are told to round to 4 decimal places. So going to the calculator, let's first find the angle in degrees. Let's press the mode key, go down to the 4th row. Notice how degree is already highlighted. If it wasn't, we would highlight it and press enter. And now we go back to the home screen by pressing second mode. And now we press second cosine for inverse cosine, and then we enter -40 divided by, now we need to be careful here because the 5 and the square root are in the denominator, and therefore we need parentheses around this product. So we have open parenthesis 5 second x squared for the square root, 145, right arrow, close parenthesis for the denominator, and then close parenthesis for the input of inverse cosine, and enter. Notice in the 5th decimal place we have a 3, and therefore we round down to 131.6335 degrees. However, to make the entry a little bit easier, what we can do on this calculator is press second cosine for inverse cosine, and then if we press alpha y equals and select this first option, notice how it brings up this fraction format. Using this, we don't have to worry about putting 5 square root 145 in parentheses. we can simply enter -40, right arrow, and then enter 5 square root 145, right arrow, close parenthesis, and enter. And of course we get the same result. So this format can be a little bit easier to use at times. And now to find the angle in radians, we simply have to change the mode. Press mode, highlight radian, press enter, go back to the home screen. We can pull up the previous entry by pressing second enter, and now that we're in radian mode, if we press enter, we now have the angle in radians. And notice here we have a 3 in the 5th decimal place, and therefore in radians we have approximately 2.2974 radians. Which again is this angle here between the two vectors. I hope you found this helpful.